Hi everyone, my name is Ghassan Matni, a cloud expert at Kloudr, which is a multi-cloud managed service provider, and I'm AWS Solution Architect certified. I've been working on AWS platform since 2015, and I already implemented complex solutions on AWS, covering most of their services. I also migrated different workloads from on-prem environments to AWS. I followed two concepts. First of all, the lift and shift, and then I have experience with the hybrid model that some companies prefer to have as an extension of their on-prem workload to AWS Cloud. In this session, we will cover AWS Cloud security concepts, such as the shared responsibility model, which we will discuss in details in the future slides. In addition to the identity and access management, or what it's called IAM, to segregate the user's permission on the cloud infrastructure. And later on, we are going to discuss different AWS security native services that you can manage from a single console. On AWS, all your security will be visible from the AWS console, unlike the traditional data center resources where you will need to log in to each component, for example, firewall, switch, load balancer, servers. So in case you need to troubleshoot any incident, so you need to log in to different components in order to troubleshoot and find the root cause of the incident. However, on AWS, from a single console where you can see and manage all your resources, you can see the logs and all security features that you would like to have or to check its logs and activities. We are going to start with the AWS security. At AWS, we call security a cloud zero job. Job zero, sorry. In other terms, their cloud security is their top priority. AWS doesn't implement or release any service without taking care of their security. When we talk about security, we need to ensure it on all its levels, starting with the physical security, network security, platform security, and end up with the people and procedures for the employees working at AWS. Security is visible on the cloud, so you don't need to worry about the data center cable management, access management, electricity, and physical security. All such stuff are managed and handled and secured by AWS employees. From AWS console, you can check the access of your resources, the date, the time, when, and what did they do. All such logging are available and visible from a single console that we are going to explore in this session. When you host your infrastructure on AWS, you are gaining security features that are validated by security experts and compliant teams working around the clock watching your back. We cannot talk about security without talking about compliances and security certifications that the host provider is having. For example, we have on AWS customers like NASA and CDC that they are using some of their services to host on AWS. And in addition, if any of AWS customers would like to implement a new security feature on AWS, and AWS release this feature will be available for all AWS customers. So in other terms, every AWS customer will benefit from the tough scrutiny of other AWS customers. And this specific feature will be available for all customers, not only specific to this customer. So regardless the customer size on AWS and infrastructure workload that is implemented there on AWS, it will have the same level of security of the biggest customer on AWS. When we talk about security, we need to talk about compliances and certifications. And AWS will have it, all of them. For example, we have AWS is HIPAA compliant. Which is for health insurance and sensitive patient data. We have the SOC 2, which is an auditing procedure that ensures your service providers which is securely manage your data to protect the interests of your organization and the privacy of its client. In addition to the well-known ISO 27001, which is the Information Security Management System. You can find the whole list of certifications of AWS compliance in a single dashboard of AWS Compliance Center, available for all people on aws.amazon.com/compliance, where you can see all the certifications and compliances for different type of businesses. Definitely AWS will handle the physical security, and all services on AWS will not be released before making sure of its security and data privacy. In addition, for every service released by AWS, different security features are also documented and released in parallel of the service. So customers can detect and implement different security measures depending on the service they are using on AWS. Now we are going to move to the shared responsibility model. It's really important to segregate the duties between AWS and customers. Some people, some organizations will require to secure their infrastructure on AWS using different levels, and AWS will be all responsible for the security of the cloud. In other terms, AWS will be responsible for the hypervisors, for the physical servers, for the switches, for the firewalls, for the global infrastructure, starting with the data center and access to the physical locations of the data centers, its availability zones. As you know, AWS, each availability zone is a cluster of data center. It's not only one data center to achieve high availability and redundancy across its AZs, in addition to the edge locations. However, customers are responsible to secure their applications hosted on the cloud. By default, AWS provides you with the services and tools to secure your workload on AWS, but there is some responsibility on the customer level, or whenever you use to work with partners, it will be the partner responsibility to do it, to secure the application layer on AWS. For example, AWS will be responsible for the physical firewall hosted behind your infrastructure. But it is the customer responsibility to apply security group policies. Security group, it is the firewall GUI on the AWS console, where you manage your firewall policies. So we cannot blame AWS for all attacks, and we cannot blame the customers for all attacks. For that case, we have the AWS shared responsibility model, which will segregate the duties between AWS, which will be responsible for the security of the cloud, of the infrastructure on the cloud. And on another hand, the customers will be responsible for the security of their infrastructure, of their application on the cloud. Using, for example, customers are required to encrypt their data on-prem, on the cloud, sorry, and to apply specific or very tight policies on the firewall to access their resources. AWS responsibility is the physical security of the data center. AWS has been designing and building large-scale data centers for many years. The key difference between AWS and some competitors is that their data centers are owned by them. They design and build their data centers from scratch, and they don't rely on third-party data centers to rent a location. They have 2 or more level of two-factor authentications and controlled and need-based access. No one can enter the data center without a logical need. And definitely they are strictly controlled physical access using 3 layers. All access to the data centers is logged and reviewed. In addition, they segregate duties between physical and logical access. For example, AWS customers, or AWS employees, doesn't know the exact address of the data centers. We all know that AWS has many regions where you can implement different workloads. However, AWS and customers, employees and customers, doesn't know the exact address of the data center because there is no necessity to have it. Only people who work at the data center in AWS know the exact address. So this is how AWS is segregating the duties of their own employees even. It is AWS responsibility to ensure the security of the hypervisor OS and the access to these physical servers will be logged and audited. However, the EC2 instances are customer controlled and AWS admins cannot log in. As you know, AWS virtual machines are backed by hypervisors that AWS are managing and secure. Customers, AWS customers, cannot access these hypervisors, for example, to check its logs. It will be AWS responsibility to do it. On the other hand, AWS admins cannot access your virtual machines even if you open a ticket with their support. If you have anything that you need to check from the console, AWS support team will not be able to access it because they don't have the access. Okay, it will be strictly the access will be strictly controlled by you as a customer using your own root account on the console and using customer-generated key pairs. And by default, when you create an EC2 instance, all inbound traffic will be blocked and you allow ports as needed via the security groups, which is the firewall rules of your EC2 instance on the management console. It is also AWS responsibility to ensure the network security against IP spoofing, packet sniffing, unauthorized port scanning at the host OS level. In addition, most updates are enrolled in a manner that they will not impact the customers. They follow a change management process that ensures that all changes are authorized, logged, tested, approved, and documented before enrolling any update. There is also a dashboard, health dashboard available to check the resources status around the clock. It's available on status.aws.amazon.com, where you can check all the services' health. And in case of anything that is not behaving well in a specific country, it will be reported on this centralized dashboard provided by AWS. Some customers during some meetings or webinars ask me, what about the deletion of data from AWS? For example, some companies host their data, their confidential data on EC2 instances or on their EBS storage. And then when they finish working or whenever they finish the task they are doing on AWS, they delete it. But the same question is repeatedly asked during meetings and by CFOs or CIOs. What about the data? It will be permanently deleted from AWS? Will AWS be able to recover these files? Or will another customer using the same disk will be able to recover my confidential files? To answer all these questions and concerns, all disks are wiped prior to use, and it can also be encrypted by customers for additional security. In case you need to add additional layer of security, customers can encrypt their EBS storage using their own key. And this way, the key will not be AWS one or any other customer will be able to retrieve it. So it will be dedicated for you. You will encrypt your data using your own key. This is as an additional layer of security. But AWS, even if you don't encrypt your own data, they have their wiping techniques are compliant with the DoD 5220.22-M, which is the National Industrial Security Program Operating Manual. It is a specified process of overwriting hard disk drives with patterns of 0 and 1s. So every data that is stored and saved, even the confidential one or non-confidential one, it doesn't matter, because the disk will be wiped using this technique, and the data will never be able to be recovered. In addition to this protocol, it is following the guidelines for media sanitization, which is the NIST 800-88. You can find more details if you just check these two protocols online. Now we are going to move to the identity and access management. At AWS, they follow the AAA concept, which is the authenticate, authorize, and audit, that ensures a proper security management when it comes to users and permissions. We're going to start with the authenticate. As a first step, once you log into AWS console and register, you will be provided by a root account, which has access to all resources, including billing. Okay, and then you need to start creating users. Creating the access to the console or any AWS resource can be categorized into 2 or 3 sections. First of all, you can create IAM users, or in other terms, a simple username and a password that will provide access to any user to AWS console to access the resources. It can be done through the same AWS console. Another method to access AWS resources or console by using an access and secret key. And this is mostly dedicated for applications access more than GUI access. So from any code or any application, even from your laptop, you can access AWS resources using these keys. In addition, you can add additional layer of security to your authentication by adding the multi-factor authentication, which can be configured through your mobile app that is generating code every 30 seconds. So in case the password is compromised by any of your users, there will be additional layer of security to enhance the access and restrict the access more on AWS. Now that we have different types of accessing or authentication towards AWS resources and console, even if we provide access to the console or resources, it doesn't mean then that we have authorized them to do specific tasks. For that, we are going to move to the second principle, which is the authorization. In the authorization section, we assign policies for each of the user. For example, user A is authorized only to start EC2 instance. So we create a username and password for user A. We assign the policy of starting and stopping only the EC2 instance to this user, and so on. So it is required to have segregation between the authentication and the authorization, because not all users have the same level of authorization under the same account. So in this way, we create different types of users, and we authorize them by assigning them pre-configured policies, or you can also create custom policies based on your need. Now, after you authenticate and authorize users to access and manage your resources on AWS, it's time to audit them. We want to have full visibility on every action by any user created on AWS. So for that, AWS has also a free native security solution, which is called the Kloudr. Kloudr is a monitoring tool provided for free by AWS, where you can monitor and log every action done by any of the user created in the authenticate principle. It will provide you all the details, who accessed, when, from which location, the IP, and what did he do, exact steps. So in case you need to troubleshoot anything, you can go back to Kloudr and check the activities of your users. Again, this tool is provided for free. Now that we have created users and authenticated them and monitored them using Kloudr, there are three principles that we need to follow when we deal with IAM, or the Identity and Access Management. When we first create the account on AWS, we will be provided by a root account that has access to every service on AWS, including billing and customer support. It's not recommended at all from a security perspective to use this root account for managing resources. Instead, we need to create IAM users, groups, and roles that have specific access to specific resources. We also have the possibility of creating temporary security credentials for temporary access. Let's take an example of the auditors. Auditors come to your companies once every year for a period, for example, of 1 month, where they need full access to the billing, to generate reports, and to check the usage. Instead of creating an IAM user and assigning a financial role to this auditor to check the bills and the monthly spend of your resources, and then this auditor will leave the company after 1 month, and you forget to revoke his access. So instead of going into this process, you can create a temporary security credentials that will automatically expire after 1 month. For example, the auditor will come at the first of the month. At the end of the month, his credentials will be automatically expired without worrying about, oh, I forgot to delete this username, oh, I forgot to revoke this access. In this way, it will minimize the risk of having anything compromised, or any username and password being compromised. Here in this slide, it's showing the root account, which is provided, and it is divided into 3 groups. We can logically group the users. For example, here we have created 3 groups: the group admins, the developers, and test group. And we assign specific roles to each group. So it will be easier for management. Some companies would like to enforce policies to their users' desktops, and most of the companies are using the Active Directories. For that, AWS has a full solution, a full SaaS solution on AWS for directory service. There are 3 types that you can use on AWS. First type, which is the most common, the Microsoft AD. Microsoft AD is a Windows server in the back end of AWS and fully managed by AWS. In fact, there are 2 servers where they installed the Active Directory role, and they configured it to host your domain. All you need to do is to log into AWS console, go to AWS directory service, and create your demo. In the back end, AWS will host your domain into 2 virtual machines, or 2 servers where the Microsoft AD is installed, and you don't need to worry at all about the replication between the 2 servers and the patching and handling all the management stuff of the OS, underlying OS. It will be fully managed by AWS. In addition, Microsoft AD supports the trust relationships with on-premise domains. If you have on-premise domain with a specific schema and you need to extend it to AWS, and this is feasible using this feature. Another type of directory service, we have the Simple AD. The Simple AD is a Microsoft Active Directory compatible directory powered by Samba 4. It has the basic functionalities of any Active Directory. for usernames and passwords, but it is limited compared with Microsoft AD. So it depends on your requirements, you choose the type. One last type you can also use on AWS, which is the AD connector. The AD connector, if you have an on-premise Active Directory and you don't want to migrate your Active Directory to the cloud, you can use the AD connector to connect AWS resources to be authenticated with the usernames or credentials of your on-prem Active Directory. It's in just a few steps to configure. You will be able to use your on-premise authentications on AWS resources. And the integration with different AWS resources is very smooth. You don't have this complex configuration to be done on the resources in order to authenticate using the Active Directory. Most of AWS resources that I use are compatible with the directory service of AWS. So you just connect this service to the directory service, and you can use immediately all the usernames and policies applied in the Active Directory. Now we are going to move to talk about the encryption. AWS ensures encryption on different levels. It is divided into two sections. We have the encryption in transit, while the data is flying between or transferred between on-prem or from anywhere you are accessing the resources and AWS. And we have the encryption at rest. It means whenever the data is residing on the EBS storage or the S3 bucket, we have different types of encryptions. As I said earlier, every resource or every service that is released by AWS, it is required to be secured, and they don't release it if it's not secured. So every service or every resource provided by AWS will use either HTTPS to access it, definitely using SSL and TLS protocols. You have SSH and RTP to access your servers. In addition, you can use a VPN service or IPsec protocol in order to connect your on-prem network to AWS network. Now we are going to move to the encryption at rest or on AWS side. We have three types or more for encryption at rest. Let's start with the volume encryption. The volume encryption, which is attached to your EC2 instances, there are also many types of encryptions you can use. You can use, first of all, the default encryption algorithm of the volume by just ticking a simple checkbox whenever you create the volume. It will be encrypted by a managed key from AWS. You can also encrypt the file system, or you can use any other third-party security provider available on the AWS marketplace. This is related to the volume encryption. Now moving forward to the object encryption or the S3 encryption, also on S3 bucket where you store your static files on the bucket. There are the server-side encryption. There are the server-side encryption with the customer-provided keys. Also, some customers prefer to encrypt their data on-prem and then transfer it to S3. This will add additional layer of encryption. Now, moving forward to the database encryption, the database encryption will follow each of the vendor encryption. For example, we have Oracle, we have MySQL, we have Postgres, and MS SQL. Each of the providers will follow its own encryption type. Now, we're going to talk about AWS Certificate Manager. Let's say one customer have multiple SSL certificates and installed on different resources. So instead of going to different resources and different services and manage the SSL aside, AWS created something called AWS Certificate Manager, which is a centralized tool to store all your SSL certificates, and it will be easy to provision, to manage, and deploy, and even renew the SSL from this console. Okay, this service that is provided by AWS also for free can be used with the Elastic Load Balancers, Amazon CloudFront distributions, APIs, and API gateways. Also, I want to mention that some resources can be installed. We can install on it free SSLs provided by AWS. You just go to AWS Certificate Manager, you create your domain, and AWS will generate an SSL that you can use, for example, on the Elastic Load Balancer, and this will be provided for free. And definitely you can upload your own SSL certificate if you have purchased it from third-party solutions. We also have another centralized tool for management of the keys. If you have different keys that you are using on different services, so instead, the same concept of the certificates, instead of going to each resource and manage its own keys from a centralized management console, which is called the Key Management Service, you can manage all your keys and rotate them based on your internal policies. Okay. Also here, you can use AWS Key Managed, and you can upload your own keys. Now we're going to move to the section of the configuration management. We have the Cloud HSM. The Cloud HSM is a compliance requirements for data security used by a dedicated hardware security module appliance that will be reserved for you with AWS. Some customers prefer to have their own dedicated Cloud HSM on the cloud and not to use the shared one available for free by AWS. So for that, you just reserve a Cloud HSM, which is dedicated module for you. It will be dedicated. And where you can deploy your keys and rotate your keys, and it will be stored under this appliance. But definitely this solution is much more expensive than the normal key management solution provided by AWS, which is native and for free. Now we are going to talk about the web application firewall, and that we will do a demo after this session on it. The web application firewall is an application layer firewall to avoid any web exploits such as SQL injection and cross-site scripting. Here on AWS, as I said, all your security services will be available and accessible from a single console. So on AWS, you just go to WAF section, and you configure your rules, and then you apply it to your resources. So with a few easy steps to configure, you will have a WAF service implemented and blocking all traffic that includes SQL injection or cross-site scripting. You can also, let's say, you can also block the access to your application from a specific IP, from a specific country, and so on. All such stuff will be handled also on AWS WAF service. The WAF rules can be purchased from a third-party vendors, such as Cisco, FortiGate, and so on. There are a full list of vendors, partners with AWS, and available on the marketplace, where you can purchase different services from them and use them on your AWS resources. Or you can use the native AWS solutions that includes free to low-cost rules that you can apply. In addition to blocking the exploits on your application, it's really important that AWS has integrated an active monitoring and tuning. So you can monitor all the requests coming to your application, and you can analyze it. And you can see all the blocked rules and blocked traffic towards your application. So from a centralized solution, you can see everything and manage everything related to WAF. The AWS Cloudtrail, as I said previously, it is a web service that records every AWS API call for your account and deliver logs. Let's take this example. We have Bill at 3:27 p.m. He launched an instance where in the US West 2 region, and where from, and it is providing us with a source IP where he initiated his request. So you can see all the logs from AWS Cloudtrail. And again, this is provided for free. You have also the VPC Flow Logs, which is a web service also provided for free by AWS that records all AWS API calls for your account and deliver logs. It is agentless and enabled per ANI or per network interface, elastic network interface. It can also enabled per subnet or per VPC. It is also integrated with CloudWatch logs, and you can also create metrics from these log data, CloudWatch metrics. This is an example of AWS Flow Logs. You have the interface ID, you have the source IP, you have the source port, protocol, packets. It's very similar to a firewall logging. Whenever you need to troubleshoot all the traffic on your network, because AWS has full control on the firewall and doesn't allow its customers to access the firewall logs. So alternatively, it provided us with AWS Flow Logs service, which allow us to check, analyze, and take action according to these logs. Okay. It also report the access if it's accepted or rejected for each packet. Now, if you don't want to use AWS native security solutions, there are plenty of third-party vendors, security vendors, that you can use to achieve different levels of security. First of all, we have the infrastructure security. You can use Cisco firewall, you can use Sophos, Barracuda, Fortinet. There are plenty of third-party vendors and their top security vendors that are available on AWS Marketplace that you can use to enhance or to adapt with the internal company compliance and policies that you have. For example, if you have an internal policy that you need to use Cisco firewall on the cloud, okay, you don't want to use the AWS native firewall, which comes by default and for free. You can purchase Cisco firewall. It is a virtual machine on AWS that you can implement, and you can reroute all your network traffic towards it. You can also use vendors for logging and monitoring, like Splunk, Alert Logic. You can enhance your identity and access management by implementing Elastic SSO solution. Also for encryption, data protection, you can use Gemalto that has its own HSM. You can also implement it on AWS if you don't want to use AWS HSM solution, in addition to Key Nexus. Thank you. Now we are going to move, I'm going to show you a demo on AWS. Okay, can you see my screen now?
Yes, Hassan, we can see your screen.
Okay. So just for the purpose of this demo, we have created one EC2 instance. It is a Bitnami instance that has a simple WordPress, a default WordPress website. Okay, and we have created a load balancer This is AWS dashboard. These are the EC2 instances that are created. This is the Bitnami WordPress EC2 instance. It has a public IP. It has a security group where you can manage your firewall policies. I'm going to edit the inbound traffic, which by default I allowed port 80, port 443 from anywhere to access the web server. And the SSH, as you see, I restricted it only to my public IP to avoid any kind of attacks. Now I'm going to move to the load balancer. There is an application load balancer created to serve the traffic accessing this EC2 instance. It has port 80 and port 443 listener. And I integrated the WAF service under this load balancer. I'm going to show you the WAF. We have created a set of rules of WAF following the OWASP top 10 rules. I'm going to switch it to classic. I implemented this WAF rules in Frankfurt region. The web ACL is the generic OWASP ACL, which includes the top 10 rules. Here are the 10 rules implemented to restrict and to avoid attacks on the application layer. So it has generic restrict sizes. If you need to restrict sizes for your application, it can detect blacklisted IPs, bad authentication tokens. This is related for the SQL injection, and it mitigates the XSS, and so on. So what I'm going to show you, first of all, the dashboard. Okay, here you can see the blocked requests. It has a summary of all blocked requests and allowed. You can also check them from here. You can also specify a default action for your rules. Now the rules are all configured into block requests. Some people prefer to, first of all, implement the WAF with only count action without blocking any request. And it's a strategy that they follow to, first of all, count the blocked requests, analyze them, and then block them. But from my side, I prefer, from a security perspective, I prefer to block everything and then allow accordingly. So what I'm going to show you is to check the conditions. For example, we have a match generic IPs. Let's show you. We have this public IPs, which is blacklisted. I added this IP as blacklisted to block my traffic. If I check what is my IP, and I add my IP to this range, now I will not be able to access the website. Let's go back to EC2 console. I'm going for the load balancer. Now I publish securitydemo.kloudr.com to serve from this load balancer. As you can see, I received a 403 forbidden because I blacklisted my public IP. Now I'm going to remove the public IP that I blacklisted, and I will retry again to show you that the traffic now will pass. As you see, now I'm able to browse securitydemo.kloudr.com. So from these rules, you can manage all your policies and restrict the access according to different conditions. You can follow different conditions and different rules. Okay, this blocking cannot be done by a normal firewall because the traffic needs to be analyzed by an additional layer that the WAF provides. So, thank you guys for attending this webinar. I hope it was fruitful with a lot of information. Now, if you have any question, you can just share it with me, and I will be able to answer it. I think we still have a couple of minutes. Okay, guys, if you have any question, feel free to reach out on info@kloudr.com, and we will be definitely glad to assist you with any question or concern you have on the security. Thank you for attending this webinar, and see you soon.